Two identical circles touch as shown opposite. P and R are the centers of the two circles. So that's P and that's R and that's the center. PQ is a tangent to the circle with center R, and triangle ABP is equilateral. Prove that the triangles ABC, so that's this triangle ABC, and the triangles PQR, that's this triangle PQR, they are congruent. So I think I'm going to start by finding the angles out in these triangles, and then try and work out the sides and see what happens. So PQ is a tangent, QR is the radius, so we can say that PQ is perpendicular to QR in the triangle PQR. So we can say that PQ is perpendicular to QR. So this is 90 degrees. And also for triangle ABC, so if we can say that in triangle ABC, angle BAC equals 90 degrees. The reason is the diameter of a circle. So BC is the diameter because it passes through the center. So BC is the diameter, and the diameter subtends an angle 90 degrees at any point on the circle. Or we can say that this, so we can say that this is also 90 degrees. So angle BAC equals 90 degrees. Okay, the next thing we are going to do is we are going to say that BP equals x. So the radius of the circle is x. So if we say that in triangle ABC, if we say that BP equals x, then BC is also equals x because that's also the radius. So BC equals x plus x, that is twice of x, so this is x. So BC equals twice of x. And if I name this point where the two circles meet, if I name it as, suppose Z, now I can say that BZ is also x and ZR is also x, because BZ is the radius and ZR is the radius. So I can say here in PQR that BZ equals ZR equals x. So PR equals twice of x. So we got one side equal in the two triangles. Let's look at the other sides. Now we know that AB is x because triangle ABP is equilateral. So we can write here AB equals x, and also QR equals x. That's because QR is the radius and the two circles are identical, so they have the same radius. So QR equals x. So we've got two sides equal. And what happens to the third side? The third side, we can work out the third side using Pythagoras' theorem because we have right angle triangles. So triangle ABP, ABC. Triangle ABC and triangle PQR are right angle triangles. So what happens is we can work out the side AC. So we can write AC square equals AB square, or I should say BC square minus AB square, and that would equal BC square is 4x squared because it is 2x, so 2x whole squared, that's 4x squared, minus AB squared is x squared, and that equals 3x squared. So AC would be square root of 3x squared, and that is root 3x. So I get AC root 3x. And you see, I can do something similar for PQ. And I can say that in triangle PQR, if I write it here, that PQ square equals PR square, which is also 2x, so 4x square, because PR is 2x, so it's 4x square minus x square, that is QR. So that gives me 3x square, so PQ would be root 3x, so that's root 3x. So ABC and PQR are congruent to each other. So triangle ABC congruent to triangle PQR by SSS congruency. So that's the three sides are equal.